Today's video is going to discuss chapter 1.7, functions. So there are two ways to identify a function. And the first is, if you remember in the last lesson we talked about mapping, and so this would be a mapping of a function. Remember, this is x, which also could be the domain, the input, and this is y, which also could be the range or the output. And so the idea is that the mapping would then connect x values to specific y values. Now the reason why this is ideal is this shows that it is a function because each x goes to a unique y, which is the definition of a function. So the x's can only go to one y. Even if two x's go to the same y, that's not a problem. The way this would not be a function is if you were to have this, I'll draw it as a dotted line, this 0 ended up going both to -2 and to -5. So in other words, if I put a 3 into this function, -2 would come out. If I put a 1 into this function, 5 would come out. If I put a 4 into this function, 5 would come out. And all that's okay because only one number comes out when I put a number in. But in this case, if this dotted line existed, when I put a 0 out, either a -2 or a 5 would come out, making this not a function. So in order for it to be a function, this would have to be gone. And now it's a function again. That's one way to see it visually as a function. The other way is what we call the vertical line test. And so if you have a graph, you would take this graph, and at any point I can draw a vertical line, and I can choose the point that I want to draw it on, and this vertical line crosses this graph at just one point, making this graph a function. However, if you look at this graph, this vertical line would cross at two different points. And because it crosses twice, this graph is not a function. That's how to identify a function. The next thing I want to practice is how to solve problems in function notation. So this is called function notation. This f typically stands for function, and so what we say is f of x equals -4x plus 7. Okay, now keep in mind this is more or less a fancy way of writing y, but the idea is then I can create problems like this, and so this basically is saying when I substitute a 2 in for x at every point in this function, what comes out? And so to solve this, what I need to do is take this 2, and I'm going to pretend that there's a 2 here, so wherever I see an x in this function, I'm going to write a 2. So this becomes -4 times 2 plus 7. -4 times 2 is -8 plus 7. So my final answer here is -1. So net f of 2 equals -1. You could put that up here. Now this problem, f of -3 plus 1 means I first need to find f of -3, and then I'm going to add the 1. So the f of -3 means I'm taking this and I'm putting it in for x. So it becomes -4 times -3 plus 1. Sorry. -4 times -3 is +12. I'm sorry, this should be plus 7. I apologize. It should be +12 plus 7. +12 plus 7 is 19. Now, keep in mind, all I've done so far is find this part. So f of -3 is 19. Now I got to take that, f of -3, which is 19, and add 1. So this is going to be 19 plus 1. So my final answer here would be 20. All right, now I'm going to have you try some. F of x equals 2x minus 3. What I want you to do is find f of 1 and find f of -2. Please pause the video at this time to practice these problems. should get negative 1 for f of 1. And then f of negative 2 is going to be 2 times negative 2 minus 3. This is negative 4 minus 3. Be careful, this is not negative 1. This is negative 7. All right, and then one last way. I'm going to change it up a little bit just so you kind of see that it matters. It doesn't have to be f of x. It could be d of h. So for example, this could be distance and this could be hours. So a lot of times f stands for function, and if the function is measuring something other than, or something that's measurable, like say distance, you might change this letter, though in reality most of the time you'll see f of x. But I do want you to see that these letters are not necessarily important. So this is going to be d of h equals h squared plus 3h minus 1. So to find d of 3, what I need to do is take a 3, and I'm going to substitute it in for the h. So basically anywhere that I see an h, I'm going to put a 3. So this becomes 3 squared plus 3 times 3 minus 1. And so if you think of it, it's h squared plus 3h. Sorry, there should be a 3. 3h squared plus 3h minus 1, which is that. Right? And all I'm doing is taking this 3 and substituting it in where the h is. 3 squared, or 3 times 3, is 9. Plus 3 times 3, 9. Minus 1. Order of operation tells me to go from left to right. 9 plus 9 is 18. Minus 1 is 17. Now, over here, this is to throw a little bit of a curveball at you. D of x. Remember over here we said, okay, this d of 3 means I take a 3 and I put it in everywhere I see an h. Same thing. The only thing is I'm going to now take an x, put it in wherever I see an h. So this is going to be x squared plus 3x minus 1. That, however, as uncomfortable as it may feel, is my final answer. You can't simplify it any further than that. So remember, if you get a variable or a letter in here, it means you're going to end up having some type of variable down here. All right, now you practice. P of t equals 2 times t cubed. Now I want you to find P of 2 and P of 0. Please pause the video at this time to practice these problems. I'm going to take this 2, I'm going to put it in for t, and so this becomes 2 times 2 to the 3rd power. Right? I got to do exponents first. 2 times 2 times 2 is 8. And then 2 times 8 is 16. Now, some of you may remember how it is if we make this a 1, how we can put exponents together, and this would be 2 to the 4th, which is also 16. And then finally, p to the 0. I'm going to take a 0, put it in for t. So this becomes 2 times 0 to the 3rd power. 0 times 0 times 0 is still going to be 0. And then 2 times 0, hopefully you remember the multiplicative property of 0. 2 times 0 is 0. Thank you for watching this video, and I'll see you in class.